more, and we will start with C1. It says, so again, we're always going to write our given. We're going to write what we want to find. If the current in a wire of a CD player is 5 milliamps, so I is equal to 5 milliamps. Now I'm going to write again below it what this is. Milli means 10 to the negative 3, so I'm just going to rewrite it. Someone was confused yesterday, and they're like, why do you have two of these variables? What I'm doing is I'm taking what I'm given, and then I'm rewriting it with the prefix. And milli is 10 to the negative 3. How long, so I want to find the time, would it take for 2 coulombs of charge, so that means to pass through the cross-sectional wire. So because it's a cross-section, I'm going to say delta Q, big Q, not little q. Little q is a point charge. This is a charge for an area. Okay, so that's the difference between lowercase and uppercase q. So this is going to be 2 coulombs. Remember yesterday when we were talking about the charge out of an electron, negative 1.6 times 10 to the negative 19? Well, an electron is a point charge. So you would use lowercase q, and then if it's an area, you use capital Q. And that's it. So I is equal to delta Q over T. So I want to find T, so I'm going to rearrange the equation to solve for the unknown in terms of the known. So because I want to solve for T, I want it to be in the numerator all by itself. So first I'll multiply both sides by T, and then I'll divide both sides by I. So delta T is equal to delta Q over I. Now, even though this is a really, really simple equation, this is where a lot of times people make mistakes because they do the algebra in their head. Okay? And you don't want to make a mistake. So this is 2 coulombs divided by 5 times 10 to the negative 3 amps, and this is equal to 400 seconds. And that's it. Okay, C3, it says if a metal wire carries 80 milliamps, so I is equal to 80 milliamps. If I put it in correct scientific notation, it would be 8 times 10 to the negative 2 amps, because it would be 80 times 10 to the negative 3. Okay. How long does it take? So I want to find T. For 3 times 10 to the 20 electrons. So now they're giving me the number of electrons. What is that all about? So the number of electrons is equal to 3 times 10 to the 20 electrons to pass a given cross-sectional area. Okay? So now I want to find the time. So I'm like, what am I going to do with that? Well, I know that I is equal to delta Q over T, so I know that delta T is equal to QI. Now remember, what do these things mean? This is going to be the total charge divided by the current. Now, the thing about it is if I rewrite this T, the total charge, well, they told me how many electrons I have. I have 3.0 times 10 to the 20 electrons. Do I know what the charge is? Is that Q? Is that Q? No. But I know what the charge is on 1 electron. So then I'm going to multiply it times 1 electron. The charge is 1.6 times 10 to the negative 19 coulombs per electron. That's the charge per electron. Now this negative sign, this doesn't really matter. I just want to find the time. So don't get hung up with this negative sign because it's 1.6 times 10 to the negative 19 coulombs per electron. Now, if you see what happens is, when we learned how to do units in the beginning of the year, this electron cancels with that, and I end up with coulombs. Is that the unit for charge? Yeah. And then it's divided by 8 times 10 to the negative 2 amps. And then when I do that, T comes out to be 600 seconds. So the reason I did this is you're going to have to do the same thing in C5. So that's why I want to show you, if they're talking about an electron, we know the charge on the electron, we can do that. All right, now we're going to look at D1. So D1, it says a 1.5 volt battery, so V is equal to 1.5 volts, is connected to a small light bulb with a resistance, so R is equal to 3.5 ohms. What is the current? So I want to find I. Now again, I always remember Ohm's law is V is equal to IR. I want to solve for I, so I'm going to rearrange the equation to solve for the unknown in terms of I. So I'll divide both sides by R, so I is equal to V over R. So it's equal to 1.5 volts divided by 3.5 ohms, which is 0.43 amps. And that's it.